In the next example, they're trying to show you the interconnection or interrelatedness between the frequency of the sinusoidal functions and its frequency. Now, these two ideas are closely related, but they have a little bit different twist on them. If we find the period of a function, we figure out how long it takes for it to complete one cycle of values. So as we've said in the sine and cosine functions, one period requires a length of 2 pi radians to be accomplished. Or if we think of it in terms of time, like I did on the Ferris wheel, it would take about 2 or 6.28 seconds to complete one rotation around the curve or the circle, or exactly 2 pi seconds to go around it. If we think of the idea of frequency, frequency then changes it just slightly where it says how many cycles can it go through in one unit of time. So how many periods or how many cycles can it go through in a length of 1 second? So if we think of the example I gave you where we have our parent function where we said that y equals the sine of theta, when this has a speed or a gear of 1, that means it should take one cycle, should take 2 pi radians to complete, or 2 pi in this case seconds to complete is what I used as an analogy. But on this, we want to figure out in 1 second how many cycles does it go through, and that is called frequency, so it's going to be 1 over 2 pi, and this is the idea of frequency. So the quick and easy idea about frequency is it's always the reciprocal of the period. So what we're doing is we're going from how long does it take for one period to occur, we're saying how many cycles does it go through in one length of time or interval. So simple idea is wrapped up in the idea that frequency is 1 over period. Here's our real world example that they want us to sort through and analyze. It says music. In the same scale, the C above middle C has a frequency of 524 hertz. Write an equation for the sine function that can be used to model the initial behavior of the sound wave associated with this C having an amplitude of 0.1. Now there are two different transformations that are being affected on our sine curve. We're supposed to write our sine curve, so y equals, we have an amplitude change in our sine curve, and they're also saying that we have a frequency of 524, so that's going to affect the period of our sine curve. Now we can do a direct substitution in for our amplitude because they told us the amplitude is 0.1. There's no necessary mathematical operations that are going to go on there. But the sine of, now this is where we're going to take care of and use that frequency. Our frequency was equal to 524 hertz. Now we know that frequency is the reciprocal of the period, so that's 1 over the period. So what we want to do is we want to convert that back into a unit of V. So the first thing is to think about how do I calculate a period? The period is 2 pi over B. So that means the frequency then is 1 over 2 pi over B, which means the frequency can be thought of as, if we take 1 divided by 2 pi divided by B, that means it's 1 times B over 2 pi. So then what we can do is we can go ahead and calculate our formula here by finding the value of B, because we know the frequency. The frequency is 524, and that's got to equal B over 2 pi. In order to calculate the value for B that goes in there and controls this frequency in period, we take 524 and we multiply it times 2 pi. Now I always want to try to leave the answers in pi rather than put it as a decimal equivalency, so we'll take 2 times 524, that should be 1,048 pi. So our equation they were looking for is y equals 1/10 of sine of 1,048 pi. So that's an example of how we use frequency and the reciprocal of the period.